how much work does it take to compress a spring with a spring constant K that starts already compressed by an amount x sub I to a greater displacement from equilibrium x sub F? So in the last example, I think we saw that if you think about what is the work involved for a displacement that takes you from zero compression to a compression x, and that was equal to 1/2 k x squared. In that sense, like if I look at like, well, how much work would it take, or did it take, to go from no compression to the initial amount of compression here at x sub I, that would be 1/2 k x sub I squared. Similarly, I could argue, I mean, really, I'm kind of just substituting like different things for x here. So I haven't really changed anything, but I'm saying like, hey, if this represents some larger amount of displacement or maybe some greater amount of compression on the spring, but if I ask like how much work did it take starting from zero compression, it's always just 1/2 k x squared, and in this case that would be x final squared. But if I ask like, okay, let's say I started out by doing the amount of work just to get to x sub I, and then I wanted to do an additional amount of work that gets me from here to here, would it make sense if the work, in other words, I'm talking about like starting already at x sub I and going to x sub F. That means I already had this. Couldn't that be represented by the difference between these two? And how does that make sense? I'm just trying to finish writing it here. How does that make sense? Well, one way of thinking about it is if I take this work that it took to get to x sub I and then add to it this work that was x sub I to x sub F, the sum of those two should equal the work that it took to get from 0 to x sub F all at once, right? And I think it does, because if you add this to this, it cancels out the subtracted term and you just get this. So therefore, I'm going to say this really must, this kind of, I think checks out the way I want it to check out conceptually. So I'm thinking that must be the correct answer. And you might say these are some weird ways to argue that. And the reason I did it that way is because to do this more formally would require calculus. And I didn't want to do it that way. So hopefully this does make sense, because we may have use for it once in a while. I think more often than not, we're just going to start things at 0 and just use 1/2 kx squared. But it's good to know that if you already started compressed, you could do a difference like this.